Hello students, welcome to all of you in my YouTube channel. I am Dr. Himanshu Sarkar. In my previous lectures, I had given the Coulomb's law, unit charge, electric field intensity, dipole, and also had given electric field intensity due to dipole in the end-on position. End-on position means what? That is the actual outside position. I have already discussed. Now I will discuss electric field intensity due to dipole in broadside position. These things are very much important for all of your ISC CBSE exam of class 12. Now before that, I request to all of the students to subscribe my channel. Okay. Now I will discuss now the electric field intensity due to a dipole in broadside position. Broadside position means perpendicular bisector position. Broadside means what? Perpendicular bisector position. Already you know what is the meaning of dipole. Already I have discussed in my previous lecture. So this is the dipole, that is the minus q charge, that is the plus q charge, that is the center of the dipole. Total length is what? That is 2L. I have to find out intensity due to this dipole at point P. P means what? That is a perpendicular. This is I am drawing. That is a perpendicular bisector. This is the midpoint. Perpendicular bisector position. This is what distance? R. So our target is what? We have to find out the electric field intensity due to this dipole at point P. P is where? P is at distance R from the center of the dipole and perpendicularly. That is called the bisector position or called the broadside position. So how to find out the intensity? All you know, you have to place, imagine a unit positive charge at point P. Here is the assume a unit positive charge at P. Here is a charge Q, this R, this length L. So what is the intensity at point P due to plus Q charge? This is plus Q charge. What is the direction? That is the E1. Positive charge, positive repulsion. So that is the direction of intensity. So what is intensity? E1. E1 is what? Intensity at point P due to plus Q charge is equal to how much? This distance how much is R? This is L. So what is it? Root over R square plus L square. That is equal to what? 1 by 4 pi epsilon naught into Q by root over R square plus L square whole square. That is what? 1 by 4 pi epsilon naught into Q by R square plus L square. That is equation number 1. I think all of you clear? No problem. Similarly, electric field intensity at point P due to minus Q charge. This is positive charge, this is negative charge. So direction is what? This. That is what? That is E2. So we consider E2, that is intensity at point P due to minus Q charge. What is the direction? This is a positive attracted by the negative, so this is the direction. What is it? E2. E2 is equal to what? 1 by 4 pi epsilon naught into Q by root over R square plus L square whole square. That is what? 1 by 4 pi epsilon naught Q by R square plus L square. That is equation number 2. Because this distance R, this is IL. So that distance what? That is root over R square plus L square. So U1 magnitude and E2 magnitude same. So from the vector knowledge, all you know, the resultant intensity should be what? Resultant intensity should be looking like this. That is if I consider this angle theta, so this angle also theta, so this angle theta and this angle theta. Because why? As we can write down E1 in magnitude and E2 in magnitude is same. This is E2 and E1 same. So resultant intensity is what? This is E1, this is E2. So I can split it. That is this is your E1, that is your E2. So the resultant intensity will be from the midpoint, mid portion, that is bisector position. So this angle theta, this angle theta. What is the component of vector E1 along this? Answer is what? E1 cos theta. What is the component of E2 along this? That is E2 cos theta. And what is it? That is E1 sin theta. That is what? E2 sin theta. Note one thing, E1 sin theta, E2 sin theta, they cancel each other. Why? Equal magnitude, opposite direction. So the resultant intensity resultant intensity at P is what? That is E is equal to E1 cos theta plus E2 cos theta. That is what? 2 E1 in magnitude into cos theta. That is your E. Again, recall, I think all of you clear why E1 is equal to 2 no. So the intensity function, that is a bisector position of this E1 cos theta plus E2 cos theta, E1 E2 magnitude same. So total intensity 2 E1 cos theta. Again, you can write down 2 into E1. E1 is what? 1 by 4 pi epsilon naught into Q by R square plus L square and into cos theta. Now recall the picture again. That is, this is the picture. That is minus Q, that is plus Q. This is the point. So this direction is this E2, that is E1. That is the angle, this is E, this is your E2, this angle theta, so this angle theta, so this angle theta and this angle theta. What is cos theta? This what? This length L. This is also L, that is what? Root over R square plus L square. So E is equal to what? 2 into 1 by 4 pi epsilon naught into Q by R square plus L square into cos theta. Cos theta from this triangle, that is what? L by root over R square plus L square. So E should be what? 1 by 4 pi epsilon naught into 2QL by R square plus L square. From this 2, that is 3 by 2. 2QL means what? P, called dipole moment. So E is equal to what? 1 by 4 pi epsilon naught into P by R square plus L square to the power 3. I think students, all of you clear? This is very much important formula. Now, if you have any doubt or any query, contact me in my WhatsApp in the description box. Thank you. I am stopping my class here.